In this video I'm going to show you how to plot two reciprocals using a table of values. So again, we are sketching, we're not looking for 100% accuracy here, but the more accurate we can be, the better. Okay, so I've got a cubic here, 1 over 2x. Now remember, cubics take that form, y equals a over x, but they can be more complicated than that. So we're going to look at a more complicated one in a minute. Now, values of x between -5 and +5, and you can see here we've got a few extra values here in this table of values. That will become important because this is where there's the significant changes. This is where cubics really come to life. So reciprocals really come to life. Now, so when x equals -5, I've got 1 over 2 times by -5. So I've got 1 over 10, which is negative as well. So negative 0.1. Now, if you need a calculator for these, you can use one. 1 over 2 times by -4. So 1 over -8, that's negative 0.125. -3, 1 over 2 times by -3, so a sixth. So that's going to be again, it's negative 0.1. So if you think about a third being 0.33, we need half of that, so we end up with 0.165 approximately. Okay, you could even keep this to 2dp if you wanted. Yeah, you can see that I haven't got that much space. Okay, -2, so 1 over 2 times -2, that's a negative quarter, so 0.25. 1 over 2 times -1, so that's going to be -2. 1 over -2 is negative a half. Negative 0.5 over 2, so 1 over negative 0.5 times by 2, so that's going to be -1. 1 over 2 times negative 0.1, so 1 over negative 0.2. So remember, if we're dividing by a decimal, that's actually the same as multiplying. So how many times does 0.2 go into 1? It goes into it 5 times, so we get -5. 1 over 0, we can't actually plot that, so we're just going to put a cross through there because that would actually give us theoretically infinite. Yeah. 1 over 2 times 0.1. Well, this is where we can start to think about how they're going to mirror each other, because we're just essentially getting rid of the negative symbol for these. So look, 1 over 2 times 0.1, that's 1 over 0.2, which we've already established is 5. So you should be able to start seeing this mirror effect here. 1 over 0.5, 1 over 2 times 0.5, that's 1. 1 over 2 times 1, that's half. 1 over 2 times 2, that's a quarter. 1 over 2 times 3, that's a sixth, which we said was 0.165. You can probably just leave that at 0.17 when we plot it. 1 over 2 times 4, that's an eighth, so 0.125. You should really know an eighth. And 1 over 2 times by 5, so a tenth is 0.1. Okay, so now we can start to plot these points, and it will hopefully start to see that shape of a reciprocal. So -5, -0.1, so I'm going to put that there. Okay, -4, -0.125, so that's getting slightly more negative. -3, 0.165, so slightly more. -2 and -0.25, slightly more. -1, 0. Well, to be honest, that's already halfway, isn't it? So we'll just have to be a little bit inaccurate. So there. -0.1, -5. Sorry, -0.5, -1. So that's here. -0.1, so somewhere here. That's -5, so that's all the way up there. So you can already see that shape that it's trying to take. So if we move down, you can see that reciprocal tape. Now, what we have here is a special term. It's called an asymptote. Now, these lines will approach the axis, but they will never actually touch it. So you end up with that, which is, you can see that they're tapering off to essentially infinity, but they will never touch the line. Okay, so they never cross that boundary. The other side, we're going to get similar situations. So let's see if we're a bit more accurate this time. 0.15, so all the way up here. I'm going to put it right next to the line this time. 0.5, halfway between 0 and 1, and 1. 1 and 0.5. So this is going to look much better. That's in focus. 2 and 0.25, so half again. 3 and 0.165, even less. 4 and 0.125, even closer to the line. And then 5 and 0.1, so something like that. And again, when you draw that up, these lines, it's really important, they're called asymptotes. They never cross the line that they're approaching. So there we go, we've plotted our first reciprocal graph. It looks something like this. Your example will be similar. I think I was much more accurate in the top right. This one here is a little bit messy. Okay, this time around it's a little bit trickier. So again, here's my table of values. I've got values between -2 and -8, so ignore that. I'm going to use -2 and -8. 2 over x take away 3. So let's start. -2 take away 3 is -5. 2 over -5 is -0.4. Yeah, -2/5. -1 take away 3 is -4. 2 over -4 is -0.5. 0. Again, we can't do 0. That doesn't give us anything. Oh no, we can. Sorry. So here we go. Look, 0 take away 3 is -3. 2 over -3 is -2/3. So I'm going to write 0.6 recurring. 1 take away 3 is -2. 2 over -2 is -1. 2 take away 3 is -1. 2 over -1 is -2. 2.5 take away 3 is -0.5. 2 over -0.5, that's going to be -4. 3 take away 3 is 0. 2 over 0 is infinite. This is the one that we can't do. Yeah, so the one where you get a 0 in your fraction, that's where it won't work. 3.5 take away 3 is a half. 2 over a half is 4. So you can see that it's starting to show that symmetry again. Okay, 4 take 3 is 1. 2 over 1 is 2. So look, 2, -2, 4, -4. This one should be 1 if our pattern is correct. So 5 take away 3 is 2, 2 over 2 is 1. 6, well, I already think this is going to be a third. 6 take away 3 is 3, 2 over 3 is 2/3, sorry, as we can see. 7 take away 3 is 4, 2 over 4 is a half. 8 take away 3 is 5, 2 over 5 is 0.4. So we can see that after we hit that cannot compute one, that syntax error one, we get that pattern returning. So now let's see if we can plot this table of values. So -2, -0.4, that's going to be here. -1, -0.5. 0 and -2/3, so here. 1 and -1. 2 and -2. 2.5 and -4. 3 doesn't work, so this should be our line that is our actual asymptote here. So let's have a look, but it looks like it approaches that line, x equals 3, and then doesn't approach, and doesn't actually touch it. Okay, 3.5 and 4, so we're starting it the other way now. 4 and 2, 5 and 1, 6 and 2/3, 7.5, 8 and 0.4. So that was a nice one to do, and we should be able to just sketch that. And remember, when you plot it, it should not meet the line that it is approaching. It does not touch it. So there we go.